Welcome to How to Pass the Chemistry Regents at chemvideotutor.com. My name is Guy Houtman and I'll be introducing myself a little bit more formally in just a few minutes. But first, to make sure you're in the right place, number one, you are worried that you might fail the Chemistry Regents again. Take this student on Twitter, said definitely going to fail this Chemistry Regent. Number two, all you want to get is a 65 so that you can move on with your life. Like this person, Peyton said, couldn't find me 1 point to pass the chemistry regents. See you in January, part 3. And then you could use a little confidence to finally pass the chem regents like Nicole. Try 2 on the chemistry regents was another failure with a 45. So if you stay until the end, you'll learn how to answer the easiest and most commonly asked concepts on the chemistry regents even if you fail the chemistry regents once or many times before. Number two, you will learn how to handle the short answer questions, sometimes without ever reading the passage. And number three, you'll learn how to get a guaranteed 65 plus on the chemistry regents, even if you failed every chemistry test all school year long. Okay, that's the reason why I keep getting tweets like this. I have so much confidence on the test I took today. Thank you so much. And then another student said, I passed. Yay, thank you so much. Like, you don't understand how much I thank you. Another student went from a 57 to a 75. This really works. And I had a shout out to chemvideotutor.com for being the main reason I passed the chem regent. All right, so this is me here. My name is Guy Houtman again, and that's what I used to look like before I had hair. Now, after 15 years of teaching, you tend to lose your hair. I am a New York State licensed teacher. I've taught in both public and private school settings. As a high school student myself, I attended Staten Island Tech. In fact, here's a picture of me when I was in high school, and despite those short shorts, that's a very proud moment because I helped my team win the New York City cross country championship at Van Cortlandt Park. Okay, I then went on to graduate from SUNY Binghamton, and I still currently work at a New York City public school. All right, and basically what I did was I went through 8 chemistry regents exams to find the easiest and most commonly asked concepts and put that together into a video series called 100 Ways to Pass the Chemistry Regents. You should receive those study guides upon sign up. Okay, and now this video series has helped thousands of students all over New York State pass their chemistry regents. And so here's how it works. In order to pass, this is from the January 2017 chemistry regents, we need a 65 right here. Well, you need 50 points. You need to answer 50 out of the 85 questions correctly. If you answer all 85, you get 100. But we're focused right now on getting a 65. That means you need 50 points. Well, June 2017, same thing. To get a 65, you need to answer 50 questions correctly, which is 50 points. And again, August 2017, 50 equals a 65. So my goal for you is to easily and confidently pass the chemistry regents. So that means to get 50 points to 65 in the shortest amount of time, even if you fail the exam many times before. Okay, take Amanda, for example. She emailed me saying, sorry. OMG, thank you so much for this wonderful program. I feel so confident right now. I finished the test in 1 hour, but that gave her ample time to look over every question carefully and take her time looking it over. She left with 5 minutes to spare, but it was not rushing at all. Thank you so much again. All right. So here's basically how this works. All right. This is again from the January 2017 chemistry regents. I went through every question, all 85 questions. I wrote down the topics and which concepts from 100 ways past chemistry regents were covered. All said and done, 60, I know this might be a little hard to read, but 60 out of the 85 questions were covered. That translates into a 72. That's correct. You could have earned a 72 it had on the January 2017 chemistry regents, on the June 2017 chemistry regents. Same thing. Out of the 85 questions, 69 ways were covered, 69 questions were covered. That could have gotten you an 80. All right. And then August 2017, again, out of 85 questions, 67 were covered, getting you to a 77. So this has built-in cushion. Remember, 50 points gets you to a 65, and we're getting to in the 70s and the 80s. All right, so here, let me give you an example of one of the videos from 100 Ways to Pass the Chemistry Regents, which is way number 18. It deals with the concept of an orbital. All right, and let me backtrack for a second here. deals with the concept of orbital, and out of 8 exams that I went through, it was on about 50% of the time. And as you could see here, an orbital is a region of high probability of finding electron. An orbital, most probable location of electron. Orbital, location of electron. Orbital, electron. Okay, so obviously an orbital is the most probable location of electron. Now, I want you to imagine something for a second. Okay, imagine this was on the June 2013. So imagine you were sitting there to take the June 2013 chemistry regents, and I know it's a while ago, but bear with me. I'm going to show you how this works even on the regents that you're going to be taking. When you open up that exam and that first question asks about an orbital, how are you going to feel? That's where the confidence comes in. You're going to have the knowledge and you're going to have the confidence, and you're going to know that it's choice 3, the most probable location of electron. That's way number 18. But here's the best part. Out of the 11 questions on that exam, 9 out of them were covered by the concepts in 100 ways to pass chemistry regents. Okay? Now, forget that. That was a long time ago. Let's go to the next year, June 2014. You open up that booklet and look at that. Question number 3 had to do with an orbital, which is not an orbit, right? A lot of students said a circular path traveled by an electron. That is a most common answer students put. But if you knew way number 18, the region of most probable electron location, you get that right. You got the knowledge, you got the confidence, and you're on your way to passing the exam. But it gets better. Out of the 10 questions on that test, what is that? Nine out of 10 questions were covered by the concepts in 100 ways to pass chemistry regents. Okay, moving on to the next year, next June 2015. You opened it up, and orbital, was it on there? No, it wasn't. But that's okay, because all 12 questions were covered by 100 ways to pass chemistry regents. Remember, there's a 50-50 chance of that question appearing on the exam. If it's there, great. If it's not, you're still backed up by some of the other concepts. Now, if we go another year, June 2016, well, was orbital there? No, it wasn't, but all 12 questions were covered. All right. And then we'll go even to January 2017. You open it up. Was orbital there? Yes, it was. It made a comeback right there. And notice, I don't know if you noticed, but all these questions are like one of the first few questions on the exam. Question 1, question 3, question 4. And of the 12 questions, all of them were covered. Actually, no, sorry, 11 out of 12 were covered by 100 ways to pass the chemistry regents. You see what I'm doing? And I'm not even done. What about June 2017? You open up that booklet. Was orbital there? Absolutely, right there. Question number 2. All right, that's way number 18. And the beauty of that is all 13 questions on the first page of that regions were covered, giving you the knowledge and confidence and the reason, like Amanda, who was able to finish the test in an hour and still pass the test. Okay, now you have 3 hours to take the test, but take your time. But again, you're going to have that knowledge and confidence. And on the August 2017 chemistry regents, orbital was not covered, but that's okay because all 11 questions on the first page were, and it just keeps going like that throughout the rest of the exam. Okay, now again, it's the reason why people tweet me. I hope to get your tweets too. Javon email me, said he basically crammed for the regions with my website. I'm extremely glad I did because everything I saw on each way was on the region. Excuse me. Thank you, and keep doing what you're doing. You're literally saving lives. A saved soul. All right. Michaela wrote to me as well. She said, "Thank you for your video. I walked out of that test so confident. I think I actually passed this time. Thank you so much." So she failed in June, probably took it again in August. All right. Another student, Andy, emails me saying, "Dear Guy, I hope this email finds you well. Your videos help so much. The region was as easy as stealing candy from a baby. Your 100 ways in your videos definitely helped. I would 100% recommend this to other people. I'm positive I got 85 plus. Thank you so much." Okay, so here's what we're going to do. We're going to get started here. I'm going to continue here. We're going to start with whenever you see the word disorder. Okay, so in 5 seconds or less, you're going to see that word. You're going to know that it deals with way number 10, which is entropy. Okay, entropy right there. That's how easy this is, okay? And just to show you some other questions here, this was from June 2016. All right, we're gonna pull up the question. It says entropy is a measure of the. Don't you already see the answer? All right, it's gonna go with choice 2. Disorder. So disorder means entropy. Entropy means disorder. But you know what? I'm not done. Take a look at this. January 2017. Which term is defined as a measure of the randomness? They threw in a different word, randomness of a system. Well, that's mixed in with the entropy and disorder, making the answer choice 2. Now listen, I know all of these questions in choice two. I can't promise you it's going to be choice two, but I can tell you that there's a good chance it's going to be right around question 20, right? Look at that, 20, 20, 21. They repeat the same questions over and over and over again. There's only so many different ways they could ask these questions, guys. So now you know way number 10. But I'm still not done because I want to give you a little advanced way number 10 knowledge right here. All right, just so you know, when we talk about disorder, we're talking about how close the particles are. See, in a solid, they're very tightly packed. In a liquid, they're far apart, loosely packed, sorry, and in a gas, they're far apart. And that's why when you go in this direction, the entropy increases. So, in this question, which phase change represents a decrease in entropy? Well, you know what? Let's say you forget which direction is which. Well, here's a little tip. I want you to see when you go from solid to liquid to gas, it goes to the right. So do that for each choice. Solid to liquid goes to the right. Gas to liquid is the opposite direction to the left, so that doesn't help. But when you do liquid to gas and solid to gas, the answer should jump out at you. Look for a pattern in these types of questions, okay? It's the odd man out. It's the one going the opposite way. And on the June 2015 Regents, let's see if you were paying attention. Now, even if you don't know what the word endothermic means, and you will because, it's going to be covered later on in the video series, you could still apply this arrow technique to these questions here. Just forget about the CO2. They all have CO2. Look at the phases, and when you apply the arrows, that goes to the right. Second choice goes to the left. Third goes to the left. Fourth goes to the left. The odd man out is obviously going to be choice one. Okay, so that's how you handle entropy related questions and say, oh, wait, well, what about short answer questions? What about that? Well, on the June 2017 Chemistry Regents, they did in fact ask a short answer question and explain in terms of particle arrangement why the entropy of the water decreases when the water freezes. Okay, so just freezing, all right, solid to liquid is when it melts, and right over here, liquid to solid is when it freezes. So it's going the opposite way. All right here. So the all you need to write down is the arrangement of the molecules is more random in the liquid phase than the solid ones. Okay. So as long as you write something that shows the person grading your test that you understand entropy, you get that 1 point, even if it's a short answer question. All right. Now you guys ready for a little quiz? Here are 3 questions. That's 3 points on the August 2017 chemistry. I'll give you a second, actually 5 seconds, to answer 3 different questions. All right, you probably got the answers already. So, when a sample of CO2 becomes CO2 gas, there's a change in particle arrangement. All right, and then number 24, look at that, entropy. That's 3 points from one video, way number 10 on one Regents. And number 22, look at that, right around the same numbers as you saw before. They got the arrow situation, and the odd man out was the answer. All right, so that right there should have just given you some knowledge, given you the confidence, and let's see on your test what's going to be around the low 20s. Is it going to be an entropy question? I hope so. All right, going on to way number 28 on how to pass the chemistry Regents. Nuclear reaction obviously is going to be a transmutation. All right, there are other types of nuclear reactions such as fission and fusion, but a transmutation is when an atom of an element is converted to an atom of a different element. It could happen naturally, it could happen artificially, which I'll go into in just a minute. So here was a short answer question asking about this concept on the June 2017 chemistry Regents. Explain why the equation represents the transmutation. And you're like, what equation? Well, even though there was no equation, there was an equation, I just didn't show it to you yet. There it is. But as long as you write one element is changing to a different element, you get that credit. But now that I showed you the equation, you could also write that hydrogen 3 is converted to helium 3. All right, that would be credit enough. But all you have to do is write definition. Transmutation is when one element is changed into a different element. So I showed you multiple choice. I showed you a short answer. Now, I wanted to point something out here. You see how the hydrogen here is the only thing on the left of the arrow? That's by itself. You see that? So this is a natural or a spontaneous transmutation. So what does artificial look like? Well, it's not going to be by itself like in this question right here. In choice one, you have the BE and you have the helium before the arrow. So the Be is not by itself. It was bombarded. That word is giveaway for artificial transmutation. It's bombarded with an alpha particle. You might recall like the gold foil experiment, maybe. Well, Ernest Rutherford bombarded gold with alpha particles. Well, these are it, right? And the Be turns into a different element, carbon, right, through nuclear decay. So this is an example of artificial transmutation. This would be example of natural transmutation. All right, but as long as you know the definition, how to recognize it, you're good to go. And another short answer question. On the August 2017 Chemistry Regents, explain in terms of elements, why the decay of Bi-210 is considered a transmutation. And you know what? There was a reading passage that went along with this, but I'm not even going to show it to you because as long as you know that a transmutation is when a different element forms, you're good to go. All right, you could get a lot more elaborate in your answers if you looked at the reading passage, but remember, I want to give you knowledge, I want to give you confidence. In fact, a little tip is read the question first before you spend the time getting confused with the reading passage. All right. And so we're going to go on to when you see break a chemical bond and they talk about energy. Well, let's see here. This deals with breaking chemical bond is way number 43. All right, so here's how this works. When you break a bond, energy is absorbed, and when you form a bond, energy is released. So they said break, so we are absorbing energy. Now here, let me give you an easier way to remember that. BARF. Now don't throw up the chem regents, but BARF stands for break, absorb, and form is when energy gets released. So let's see if we could barf on another question right here. What occurs during this energy change? Well, you have two BRs that are together and now they're separate. So they broke. Okay, so when you break, you absorb, so it's going to be one or two, and we broke right there, so the answer could be choice two. All right, and let's go to another one. Now here we have two eyes that are separate from each other, and they're forming two eyes that are connected together. So we are forming this time, and therefore a bond is formed, the energy will be released. Okay, and by the way, before I switch over here, look at this, number 14, number 16, number 10, right around the same question numbers, they tend to have about barf. Okay, January 2017. All right, maybe not. This was here a little later, maybe a little bit more advanced, question 38. But here we have H2, we have I2, and we have HI. Now, look at this. They said absorbed, so it should be break. No. They said released, so it should be formed. No, they're confusing you. All right, but it should be barf. So if energy is absorbed, bonds are formed. No. Choice 4, absorbed, break, and release, form. Choice 4, every single time, barf. And then we're not done. We got short answer questions. June 2017. State the change in energy that occurs in order to break the bonds in the hydrogen molecules. And you know what? There was a reading passage that went with this. There was a reading passage, but as long as you see the word break, then you say absorb, barf. Okay, there's the reading passage or the little equation that went with this question. But you didn't need to see that, did you? You didn't need to see that. When you see the word break, absorb. Okay, how about August 2017, multiple choice. Notice back to number 12. And what are the H's doing? Well, you have two separate H's, and then they are forming two H's connected together. So we're going to form, and when we form, energy gets released. Choice 4 right there. How you feeling right now? You feel good? All right, great. If you're getting some value out of this, then I want you to pause the video, take a picture or a screenshot of this, and share it on your social media sites because this guy is going to help you pass the chemistry regents. On Twitter, my handle is at a ChemVideoTutor. On Instagram, it's just at ChemVideoTutor, and throw in that hashtag ChemVideoTutor. This way I can find it very easily. And by doing that, I appreciate it. You let me know that whatever I'm telling you right now, whatever I'm showing to you and explaining to you, you're finding very helpful. So once you're done with those pictures, all right, you could start playing a video again because I'm going to be dropping some more knowledge bombs, and we're going to move on to this topic right here, which deals with empirical formula, molecular formula, which happens to be way number 55 on how to pass the chemistry regents. So when you're going from molecular formula to empirical formula, you want to divide by the greatest common factor. So here, let me show you what we're going to do. We want to get the molecular formula, which is just counting all the C's. We got 1, 2, 3, 4 C's. You got two H's, two N's, and we got 1, 2, 3, 4 O's. Okay, that's what's known as a molecular formula. Excuse me. I like to call it the MOFO. Okay, so the MOFO is C4H2N2O4. Now, to divide by the greatest common factor, all right, pay close attention to those numbers. The greatest common factor there is 2, right? So when you divide C's, the 4 divided by 2, you're going to get 2 C's. 2 divided by 2 for the H is 1. 2 divided by the 2 is 1N. All right, and you got 4 divided by 2 for the O's, you get 2. So C2HNO2, making the answer choice 4. That's how it works, guys. Here, let's try it again. What is the empirical formula of a compound with the molecular formula N2O4? Greatest common factor is 2, and we're going to end up with NO2. Guys, did you notice the question numbers? 36 and 36. I don't make this stuff up. Okay, let me go back again. 36 and 36. MOFO, molecular formula, divide by the greatest common factor, and you get your empirical formula. So let's see how this works. Check this out. This is going to be pretty cool. On the June 2014 exam, a short answer question, write the empirical formula for glucose. Now it tells you right here that glucose has a MOFO, molecular formula, of C6H12O6. And so divide that by the greatest common factor. And for some of you, for all of you, it should be 6. So 6 divided by 6 is 1. 12 divided by 6 is 2. 6 divided by 6 is 1. You should end up with here, I did the math for you already. I didn't realize that. All right, so we have C6H12O6. We're going to divide that by the greatest common factor of 6, and you end up with an empirical formula of CH2O, just like the answer key said it should be. And no, the order of the elements does not matter. You could put the H first, the O first, the C first, but we'll just go with CH2O. All right, now check this out. On the January 2015 chemistry regents, all right, I'm going to give you the answer first. Let's play like Jeopardy now. What do you think the question was? If the answer was CH2O, the order of the elements can vary. And by the way, look, it was 53 on one test, 57 on the other. All right, guess what? They were probably asking about the empirical formula for glucose. Talk about repetition right around the same question number. And that was without the reading passage that they provided to you, okay, where they tell you that glucose is C6H12O6. Well, you should already know from living environment, and now you know from chemistry, and now you know from me that glucose is C6H12O6. The empirical formula is CH2O. And you know what? I'm still not done because on the June 2016 chemistry regents, guess what they asked? Guess what they asked? Question 70. That was the answer. Guess what they asked? Write the empirical formula for glucose. Again, I'm not making this stuff up. They repeat questions over and over and over again. Now, what if they change it? And by the way, there was a reading passage. Reading passage yet again, right, where they tell you that glucose is C6H12O6. You don't need to read that. Read the question first, see if you could answer it, and then go back to the question, the reading passage, see if there's additional information that you may need to help you out. All right? Now, it's not always going to be glucose, but you know how to do it no matter what, right? Which molecular formula is also an empirical formula? Well, here, just divide everything by its greatest common factor, and the one that is the same before and after is going to be the answer. And a little tip here is look for odd numbers. Odd numbers, like right here, 5. Well, the greatest common factor here is going to be 1, right? So N2O5 is still going to be N2O5, both MOFO and empirically, right? This could be reduced, this could be reduced, this could be simplified. And look at that, it was number 35. Didn't we see that before on another test? And then, short answer question. June 2017, write the empirical formula for ethene. Wait a minute, that's not glucose. All right, well, if you don't know, go look at the reading passage, and they tell you right here, ethene gas is C2H4. Do you think you'd divide by the greatest common factor and end up with CH2? Again, the order of the elements may vary. That's an easy 1 point for a short answer question where this time I admit you do need to read the reading passage, but now you know exactly what to look for, don't you? And guess what? Another short answer question, August 2017. They said the liquid compound has an empirical, they're telling you the empirical formula of C is CHCl. Now they want the MOFO. They want you to do it backwards. Well, what we need to do, again, is sometimes look at the reading passage. And because we have the liquid compound, all right, so that means we got to look at the liquid here and see it says 1,2-dichloroethene. Well, that sounds similar to that one, right? Well, the other thing you want to realize is there's one C, there's one H, and there's one Cl. Well, if they're all one, then they all need to have had the same number, like here, like 6 and 6. It all simplifies down to 1. Well, it tells you right here is a little secret. Dichloro means that there's two chlorines, which means there had to be two C's and two H's. And when we look at the answer key, there it is. C2, H2, Cl2, the order of the elements may vary. So how's that for knowledge and confidence for way number 55? Okay, we're going to move along here to when you see questions dealing with equilibrium. That word right there is way number 81 on how to pass the chemistry regents. Now, there's two different ways that they tend to ask equilibrium questions, specifically definition wise. The answers will always be the rate of the forward reaction is equal to the rate of the reverse reaction, or the concentrations are constant. Here, let me show you. Which two factors must be equal? Well, the rates are equal. Okay, so the concentration, no. The number, no. The rate right there. The rate of the forward reaction and the rate of the reverse reaction will be equal every single time about equilibrium, or it could be the concentrations are constant, and notice equilibrium, and they're all asked about concentration. Well, is it greater, less than, equal to, or constant? Don't confuse the two. This is asked about the rates, and this asks about the concentration, constant, every single time. Okay, how about a short answer question? Short answer question, January 2015. Explain in terms of the reaction rates. They're asking about this. Why the concentrations of the reactants remain constant. So they're telling you this and they're asking about that. So they told you it was constant. So all you're going to say is that the rates are equal. Okay, you can say the rate of the forward reaction equals the rate of reverse, or very simply, the reaction rates are the same. They would accept that. That was one point. Short answer question. Okay, way number 81. But you know what? I'm not done. I want to prove to you even more. You might think my videos are outdated. Well, guess what? I got news for you. All right. By the way, that was with the reading passes that you didn't need to read. And just to prove to you that it's not outdated, January 2017, question 44. And look, if we go back, that was question 45. And then we go forward. This is question 44. And look, concentration, concentration, concentration. Well, we know that the concentrations are constant. Boom. And still not outdated. June 2017, when a reversible reaction is at equilibrium, the concentration are constant. Repetition, guys, over and over again. And I'm still not done, because on a short answer question on the August 2017 chemistry regents, they wanted you to compare the rate of the forward reaction with the rate of the reverse reaction at equilibrium. And because they're asking about the rates will be equal or the same. And again, no need to even look at the reading passage. How do you feel about that now? Okay, now let's take a little break here. Let's see if you agree with these tweets. Have you been only watching the video for 15 minutes and have so much confidence? Thank you so much. Do you agree with that? How about this? I watched about 20 minutes of your video and learned more than I ever have in the past 10 months of chemistry class. I hope you feel that way, right? And then another student said, a Chem Video Tutor, his videos help so much. I wish I watched this shit earlier. All right. And we got one more. Mr. Hauptman, today in the chemistry regions, I found many of the questions that you cover in the videos, and I have to say that your videos really helped me with the test. All right. Ready to continue? Let's go on. Oh, there's another one. Thank you so much for the videos. You helped me a lot. First three questions contain electrons, and I used BARF on one of them. Short answer had the rate of the forward and rate of reverse are equal to each other. I applied all your techniques to all the questions. I'm 100% sure I scored at least an 80. Wow. You know what? I can't wait to get email from you saying something similar. Okay, now let's continue. Now we're dealing with organic structural formulas here. So what we're going to do is we're going to go to, when you see pictures like that, questions like this, is way number 98, organic functional groups, which are found in table R. Okay, now which type of organic compound is represented by the structural formula shown below? Well, notice you have a bunch of C's, you got a bunch of H's, but then there's this thing that stands out right there. So if you're not sure, you go to table R and you see that it is in alcohol. That's how easy these table R questions are. Let's look at another one, 44, just like 49 over there, right? Now here, A little bit different. This compound is classified as an, well, you got C's, you got H's, you got O. It's not an alcohol. It doesn't look like that. So we're going to look for something funky. Look for the funky part. And if you go to table R, you'll see, all right, this has an N in it, just like this does, but this has the N and has a C. It's got the double bonded O right there. So that's an amide, and that's what we're going to go with. Choice one. All right. Now, look at this 24. Which class of organic compounds has molecules that contain nitrogen? Well, that had nitrogen, but amide isn't a choice. Well, amine is, and that's going to be the answer. So just take a look at table R. Half the time, it's like right there in front of you. Okay. And we want, how about you want a short answer question? Let's do it. January 2015. Identify one. There's more than one. They just want one organic functional group in a molecule of lactic acid. And even if you didn't know it was lactic acid, right, you should know that that's an alcohol. And then this one here looks like an alcohol, but it has a special feature. So here's what we could do. 1 point. You could write alcohol. You could write OH. But this here is COOH. That is called an organic acid, as you can see right here. The COOH, they do tend to ask about this one a lot, so I want to spend some time on it. All right, it's also pronounced COO. So if you see a COO, that's an organic acid. You could just write acid. Any one of these, there would be acceptable answers for that short answer question. All right, let's continue here with another multiple choice question. Which atom is bonded to the carbon atom in the functional group of a ketone? So let's pull up the ketone right here, bonded to the carbon atom. Oh my God, what is that? That's oxygen. That was a giveaway. All right, let's continue over here. Write the name of the class of organic compound. Now, when they ask for class, they want this column right here, class of organic compound, to which both geraniol and linalool, I can't even pronounce that, right? Well, no, a little hint here. Alcohol ends in OL. Cholesterol, all right, it contains alcohol in it, and or these OH functional groups, I should say. And so these are alcohols. So all you have to write is alcohol. That's it. Class of compound organic functional groups. Do I make myself clear? But, I'm not sure I do. So I want to prove to you on the most recent exams, January 2017, short answer question, class of organic compounds to which the product is after the arrow. Oh, look, Cu. Haven't we seen that before? Well, Cu is for an organic acid. That's it. Class of compound. You're going to write this column right here, organic acid. And let's continue. June 2017. This question was like the Regents. See, I want you to pass, but I think the state wanted you to pass too, because now sometimes they give it to you in different form. Well, notice there's the N. There's the N. But look at this. It's straight from the reference table. CH3, CH2, CH2, NH2. That's from an amine. Okay, so that would be the name, 1-propanamine. It's exactly what it is in the reference table. All you got to do is focus on what they give you here and see if it looks like something in common in table R. And just to show you again how me and the chemistry Regents, the state wants you to pass, all right, this structure right here, the C double bond OH, that's the same one that was covered right here. Look, you have CH3, that's CH3, then you got CH2, and then you have the C and the O double bond with the H. That's called propanal, which makes it choice 2. Okay, and one more short answer question. This was also on the August 2017 chemistry Regents. The class, again, that's going to be the first column, of organic compounds to which the product, again, after the arrow, belongs. Well, you see how it has a chlorine right there, which stands for chloro. Well, the class is going to be halide or halocarbon. It doesn't get any easier than that. So far, let's do a little recap right here on the January. And I'm just doing January 2017, June 2017, August 2017. Those exams, I showed you how to answer multiple choice and short answer questions. Okay, wouldn't you agree? And I covered 7 different topics of chemistry right here. We did solid liquid gas, atomic concepts, nuclear chemistry, bonding, formula writing, kinetics, equilibrium, organic chemistry. 7 different concepts. And we talked about way number 10, which deals with entropy. We talked about way number 18, remember orbital, the most probable location of electrons. Way number 28, you got artificial natural transmutation. Don't forget about BARF, way number 43, MOFO to empirical formula, and equilibrium, rates are equal, concentration is constant, and the functional groups, which can be found in table R. Okay, so just from those 7 videos, you could have earned 7 to 9 points on three separate exams. And with 7 points, well, let's see that. Let's do if we do the math. Oh man, we need about 43 more points to pass with a 65. Remember, the magic number is 50, and we still have 93 videos left to get through. 93 is unbelievable. Well, I would agree to value your time. No, 93 videos is a lot to get through, but I really do value your time. So you have two choices at this moment. Okay, choice number one is you can go into the exam with what I've shown you today in the hopes that you pass, or you can watch the entire 100 Ways to Pass the Chemistry Regents video series and get a guaranteed 65 plus. Yes, guaranteed is in capital letters, and it's for a reason, because that's how confident I am in this video series. And not only that, I'm going to underline it about 20 times. That's right, 20 times I'm going to guarantee that you pass, and here's why. In the last 20 chemistry regents exams, going all the way back to 2010 and even beyond. I just ran out of room on the screen here. Okay, 20 chemistry regents. There have been at least 61, or sorry, 60, which is a 10-point cushion. And that's the reason why students are getting grades in the 70s and the 80s, right? So here, look at Jerry, August 2015, chemistry retake. Guy, I did it. I passed the chemistry retake in August with a 70. I just got my results back this morning, and I'm the happiest teenager living. Thank you so much for helping me out. You are the best study source for the chemistry regions. Thanks so much, guys. Stay awesome. Then back on Twitter, someone wrote to me, found out today I passed my Regents. Thank you so much. Your 100 ways made it so much easier. You are the reason I passed. Another email, good afternoon. I'm emailing you to inform that I passed my chemistry Regents. Your 100 ways are very helpful and easy to remember. Thank you. Okay, take a look at this. This is from August before the chemistry Regents. A girl, Becca Grace, said she failed in June, but she's been in Starbucks every day studying, and today she came across who else? A Chem Video Tutor, and it's helping so much. Gonna pass in August. She's got confidence. This is before the test. Look, she even wrote barf. She was taking notes. Okay, and then during she wound up buying 100 Ways to Pass Chemistry Regents. I'm learning more from a Chem Video Tutor in 3 hours than I did from my chem teacher in 10 months of classes. Okay, and then after, of course, there's an after. Notice you got August 5th, August 13th, and then August 26th. Thanks to your series, I passed the Chem Regents in August. Your videos helped so much. Thank you. And now it's your turn. But before I tell you more about 100 Ways to Pass the Chemistry Regents, I have to tell you what it's not. Okay? See, you're not going to be sitting for 7 hours in a classroom or a lecture hall in one day like you will with a crash course. You're also not going to be paying a very expensive fee for a course that's not even refundable if you fail. With 100 Ways to Pass the Chemistry Regents, you could get through the entire video series in half the time of a crash course. In half the time. Plus, you'll have unlimited access to the entire video series for 330 days at a fraction of the cost. $119 is a steal compared to a crash course, because you have half the time. You could watch it in Starbucks if you wanted to. Plus, like I said, you'll have unlimited access for 11 months, which is 330 days. And just in case you fail, you could take the Regents again and again and again. But guess what? A, you're not going to fail. And B, it also comes with a 100% money back guarantee, right? I don't know a single tutor or a single crash course that's going to give your money back in the event that you fail. But I will. That's how confident I am in this program. And I want you to have that confidence as well, that in the event that you fail, here, let me explain to you how the money back guarantee works. If after watching 100 Ways to Pass the Chemistry Regents in its entirety, you end up failing the Chemistry Regents, simply email me back with your failing grade and your certificate of completion, which you get upon watching the entire video series anyway. Will gladly refund 100% of your purchase price. Just make sure to do that within 30 days of the exam. Okay? Now, if all this video series did was get you a 65 on the Chemistry Regents, would it be worth it? Okay? And also, if it allowed you to be done with this exam so that you could focus on your other subjects, would it be worth it? And if all this video series did was let you graduate with an advanced Regents diploma, would it be worth it? Now, if you answered yes to any one of those questions, any one of those, then what I need you to do right now is below this video, click the Buy Now button. You'll be enrolled in the course. You'll get access immediately. You'll have access for 330 days. Comes with a 100% money back guarantee. and you will have knowledge and confidence to pass your chemistry regents. Now, if you have any questions, you could reach me on Twitter. You could email me. I'm on Instagram, Facebook, Snapchat. Okay. Now, if you haven't already, pause this, share this video, share this picture on Twitter, on Instagram. Make sure to include the hashtag ChemVideoTutor, and then go and click that buy now button before it's too late. Now, for sticking it out this long in the video, I want to share with you a few bonus items. You see, I went through the entire January 2018 Chemistry Regents and found every question that could be answered using the 100 Ways video series. For example, way number 98. We saw this in the video earlier. Here was a short answer question, and using the concept from Table R, how to answer it correctly. Now, normally this entire study guide, which could have gotten you a 79 on the January 2018 Chemistry Regents, I sell standalone for $15. But depending on when you watch this video, you can get it as a limited time bonus for free when you buy the 100 Ways video series together. Okay, now I'm not going to stop there. I also did the same thing with the June 2018 Chemistry Regents, where you could have gotten a 75, where same thing, I went through every question. In this case, you had a short answer question here and a short answer question here. So you got 2 points from one concept on this exam. Same thing here, standalone is $15, but depending on when you watch this video, you can get it for free when you buy 100 Ways to Pass the Chemistry Regents. And I'm not going to stop there. We're going to got one more in August 2018. Chemistry Regents, you could have gotten an 80. Same thing. Again, way number 98 appeared. Again, as a multiple choice question this time and a short answer question. Once again, 2 points from one concept. Standalone price is $15. Yours for free, depending on when you watch this video, when you buy the 100 Ways to Pass the Chemistry Regents video series. And I'm going to go one step further. I have a limited time bonus. Number 4 is my Regents Chemistry video series, where I walk you through every question of the January 2012 Chemistry Regents. I know it goes back a long time, but the concepts don't change. Okay, question by question, multiple choice, short answer. This sells for $47. Yours for free, depending on when you watch this, when you buy the 100 Ways to Pass the Chemistry Regents video series. So here's what you're going to get for just $119. You get the 100 Ways to Pass the Chemistry Regents video series, and anything in this box. These are the bonuses that I just spoke about. You got the 3 study guides, and then you got the Regents Chemistry video series, but depending on when you watch this, they may or may not be available. Okay, but they're yours for free depending on when you act. All you need to do is click at that buy now button below this video. Okay, you get a $211 values for just $119. Plus, don't forget the 100% money back guarantee. Now, if you don't want any of these things to expire, and if you happen to be taking the geometry regents, well, you're in luck. We have the Advanced Regents Diploma Bundle for 2019, where when you buy both the chemistry and geometry courses together at the same time, you will get $147 in free bonuses. Here, let me walk you through what's included in this bundle. You got the 100 Ways to Pass the Chemistry Regents video series. You got the 40 Ways to Pass the Geometry Common Core Regents video series. Those together is $188. And when you buy those together at the same time, you will get all of these things for free. That's the Regents Chemistry video series, the 3 study guides for chemistry, the 3 study guides the same year for geometry, and the cheat sheet for 40 Ways to Pass the Geometry Common Core Regents. Total value $335, but yours right now. These do not expire for just $188. So the choice is yours. The sooner you act, the better off you'll be. And regardless of what you do, I hope to see you on the other side. But no matter what you decide, I wish you the best of luck on all of your Regents exams. And one more time, if you found this video helpful in any way, shape, or form, please let me know. Share this picture, share this video, tell your friends, and that's going to be the end of this video, and that'll be it. So take care and best of luck to you. And if you have any questions, just shoot me an email or give me your feedback. I'd love to hear how you do on your Regents exams. Take care and have a great day.